Okay, so this will serve as the video, well, test tutorial video on the Gaussian integral. What we're going to be doing next meeting. The idea behind this is I'm going to do the proof, or the solution rather, and I'd like you guys to just tell me if there's anything you guys find confusing or doesn't make sense. So anyway, we're going to start off, this is the integral. I is equal to this, and this is what we're trying to solve. So the first step is that, well, first of all, it's an improper integral, so we kind of want to break that up. And our idea is, well, let's check whether or not it's an odd or even function. So let's have e to the negative a squared. This is equal to b, all right? And then e to the negative times negative a squared. Well, that's just equal to e to the negative a squared. And we just said that was equal to b, so it's b. So therefore, oh, therefore, right, e to the negative x squared is equal to an even function. So this is an even function. Okay, so given that fact, we can then break this up from 0 to infinity, right, times 2 of e to the negative x squared dx, right? From 0 to infinity is the same from 0 to negative infinity. Since those two are the same, we can just double it, right? We can double this. So I is equal to this. Okay, nice. So our next step here is, well, this whole technique is this idea of a Feyman integration or Feyman technique. Basically, we have some sort of function and we want to put like a variable somewhere, and then we're going to do something with that. So what we're going to do actually is the following. We're going to have some sort of function I of t, okay? And this is equal to from 0 to t e to the negative x squared dx. And then we're going to square it. It'll make sense later on. This is just part of the solution. So what we decided is we're going to put t here, okay? And then we're going to consider then, so what we're going to consider that, well, actually let's properly evaluate this. Let's do that same integral, 0 to t, okay? E to the negative x squared dx, and this is all squared, right? So how are we going to make this useful at all? Well, we actually want this, we want this integral, and this integral is equal to this integral here. So how do we make it look like the same? Well, first of all, let's get rid of this squared, right? So we'll square root it, right? And then we're going to want to multiply it times 2. So multiply times 2. And then limit as t goes to infinity. Right? And we can kind of see if I square root this, these things cancel out, right? Times 2 with the 0 to infinity, it's essentially the same thing. So I'll actually rewrite this, right, as limit as t goes to infinity, right, of 2 times the square root of I of t, right, this thing here, I of t, which is actually equal to our original integral here. That's equal to I. Okay. So without that out the way, let's clear this up a little bit. Yeah, I'll clear all this up. And we'll just rewrite our statement here. So I, which is equal to integral from 0 to infinity times 2 of e to the negative x squared dx. This is equal to the limit t goes to infinity of 2 times the square root of I of t. Okay, I'm going to square this out because we're going to need this for later. Now, moving on to our next step, we're going to, again, I'm going to rewrite our integral here. I of t is equal to 0 to t, all of this squared, I'm going to put the bracket there preemptively, 0 to t e to the negative x squared dx, and like I said, this is all squared. Now, here's the next step here. I need you guys to remember, consider this fact, okay, consider that when taking the derivative of some integral, right, derivative in respect to some arbitrary variable, okay, from a to b, right, and then, I don't know, some function, f of x, right, f of x dx, right, we're taking the derivative of an integral. What does this equal? This actually gives us f of our upper bound, f of b, times the derivative of b, so d by dz of b, right, minus f of a times the derivative of our lower bound, d by dz of a, right? And this is FTC part 2, right? Derivative of an integral. So given this formula, right, or rather this theorem claim, we can now rewrite our d by dt of our integral I of t. This should equal now, so given chain rule, right, the 2 comes out in the front, and then we've got our original integral, right, 0 to t, e to the negative x squared dx, right, like I said, chain rule, right, the exponent 2 comes down, minus 1, right, so 2 minus 1 is just 1, so we're left with 1 up here, and then our inside stays, right, but now we need a derivative of the outside, right. Remember, it's x squared is equal, well, d by dx, right? This is equal to 2x dx, right? Derivative of x, derivative of our inside. So what's the derivative of our inside? Well, right, given FTC part 2, it's the function inside the integral with our upper bound. So it is e to the negative t squared, right? Times the derivative of our upper bound, right? So it's d by dt of t, right? That minus e to the negative 0, right? Because 0 is our lower bound, e to the negative 0 squared, right? Times d by dt of 0. Okay. Let me shift over. I don't think we have more room here. Maybe I can just copy this. Control X. Okay, nice. Good, 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 good. Delete that. Delete that. Okay. Right. How does this work? Paste? Oh, okay. Yeah, so we got this, right? We evaluate all these values here, so now we have I prime of t, right? We took the derivative, I prime of t. This is equal to 2 times our integral from 0 to t e to the negative x squared dx times, so e to the negative t squared, we've got that, yeah, sure, nothing changes there, was derivative of t in respect to t, was just 1, right? So this gets, I'm not going to bother writing that, right? Minus e to the negative 0 squared, which is just 1 again, right? But what's the derivative of 0, right? It's regardless if it's 0 or some constant, right? It is going to be times 0, right? Derivative in respect to some constant 3, 4, n, right? And x, right? These n's actually cancel out to be 0. So this whole term at the back here it gets removed. So we're actually left with e to the negative t squared. And I'm going to simplify this a little bit more. So 2 integral from 0 to t e to the negative x squared minus t squared dx, right? Remember our exponent rules, right? Same basis, a to the z, right, times a to the, I don't know, y, let's say, right? It's a to the z plus y. This is regular exponent rules. Division is obviously subtraction. Yeah, whatever. All right, we have this. I can probably actually simplify this even more. I'm gonna, one more time, 0 to t, and I'm gonna take out these negative signs out here. So e to the negative x squared plus t squared. Just make it a little bit nicer. There we go. So now we have I prime t. Oh, that's the next step here. Sorry guys, we're gonna have to do a change of variables is what we're gonna have to do. So actually, I'm gonna copy. Can I copy this? Yeah, I think I can. Control C. Okay, I think this should work. I prime of t equals, boom, this. Yeah, that's what I want. And then I'm gonna save this whole thing. So X, and then let's erase all of this. Okay. Yeah. Yeah. Nice. Paste. Okay. So this is our integral. This is what we have so far. Next step is we want to change the variables. Okay. Again, all these steps, it's like, I will admit they're not intuitive, right? But the idea is, okay. The idea is the steps make sense algebraically at least. So bear with me. Anyway, the change of variables we're going to do is x. X equals u of t, okay? So dx is actually equal to, what is dx? Dx is, okay, you know what? I'm going to rewrite this as xtu, and then that means that oh my god, my dx is equal to t du, okay? So, given that, okay, that means that as x, right, approaches t, we therefore have that u approaches 1, right? We can kind of see that given this equality. And then as x approaches 0, right, that must mean therefore that u approaches 0, okay? So we can now actually rewrite, given all these conditions, right, that u as a function of x is equal to x over t, right? You see that x goes to t, we get 1 of t over t, which is 1, so u is equal to 1, right? X is equal to 0, 0 over t, u is equal to 0, okay? And we'll see why that's important, because since we're changing variables, right, we have to evaluate the bounds. So our lower bound, right? Yeah, actually we'll do our upper bound first, right? We have u of t, right, equal to t over t, is equal to 1, right? So our upper bound is 1, and then u of 0, that's our lower bound, right, is 0 over t equals 0. Okay, so these are our new bounds, okay? This is our upper, and this is our lower, right? Just like when you guys do trig sub, right? Change the variables of, I don't know, theta, right? You have to evaluate the bounds, right? You have to find some sort of function that then gives you the u upper and lower. So I'll finally be able to rewrite this as I prime of t of 2 equal sign 2 of 0 to 1. Sorry. Oh my god. Sorry about that. E to the negative x is what? X is tu, so x squared is t squared u squared, t squared u squared, plus t squared, right? Don't need to change that one. And then dx is t du. Okay. We can actually simplify this more. So I'm gonna take that. I'm gonna delete all of this here. Delete, paste. There we go. New integral again. I'm gonna simplify this one more time. I'm gonna write it here actually. Okay. I'm gonna put the 2 inside. Okay, because I can. And you'll see again with the next steps why I'm doing this. E to the negative, and I'm going to take the t out also, okay? So t squared comes out. So we have u squared plus 1, right? 2t du, right? The 2 came back in, and yada, 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 so therefore, so forth. You get it, right? I'm not missing anything, am I? No, I think I'm good. Yeah. The only thing that kind of might give you a hint of what the next step is like look at this inside term. Okay, we've got a u squared plus 1. Keep that in mind. Maybe that'll send off alarm bells in someone's head. I don't know. So the next step is to actually another consider. Okay, is I guess I could write it out like this, right? Integral of f of x, right? F of x dx is equal to big F of x, right? And therefore, that must mean that the derivative of our big F of x must then equal our small, right? Right? This kind of obvious, but you'll see why I'm stating this. Okay. Let's take the integral. Okay. We're gonna take the integral of e to the negative t squared u squared plus 1, right? 2t dt, okay? So we're taking this sort of, and we want to take the integral, but in respect to t this time, okay? And the reason why is when we take it in respect to t, it's actually doable. The derivative is actually easy, because remember the initial issue with this, right, is that there's no x here, right? Because we know if we took the derivative of this, right, would actually end up yielding like something like e to the negative x squared, right? And then you have the negative come out here with your 2, right? And then the x, right? You have this term here that's just non-existent in our original integral, right? But here we have a t. We have a t on the bottom. So it doesn't actually end up being that bad. So we can actually do it. So some slight observing, I think, yeah, the antiderivative of this, right? What would that be? Let's see. E. And well, first of all, we know this is always going to be the same, right? E to u squared plus 1. Okay. And then yeah, I have to jump a couple of hoops here. If I took the derivative of this, right? This is why I wrote this, right? Derivative of our integral product, what we get from our integral is going to equal what's inside. So given that idea, I can think in my head, if I take the derivative of this derivative is going to give me this inside. So u squared plus 1 on the bottom, right? Because if I take the derivative of this, yeah, I get the negative that comes out. Oh, actually, there's no negative in here. So I need a negative sign here, right? And then the 2 is going to come out, the t is going to come out, and then I'm going to get, yeah. Okay, let me write this explicitly for you guys, okay? If I took the derivative of this, right? Look what this gives me, okay? Look what this gives me. Bear with me. We have negative e to the negative t squared, right? U squared plus 1 over u squared plus 1. And then, like I said, I'm taking the derivative of it. So what happens? The negative sign comes down, chain rule, or power rule even, right? 2 comes down of the t, right? And then after we have this whole term here, right? Times u squared plus 1, right? And then, right, derivative of t is just 1, but I'm going to write as dt, just so we can really make it explicit, okay? Now, I'm actually going to change color, just because we're canceling things out. The negative signs cancel out, right? This bottom term cancels out, right? And as a result, this is what we're left with, okay? We're left with e to the negative t squared, right? U squared plus 1. And then we have 2t dt, right? This here is the same as what we had originally, right? Given, I don't know, like FTC part 1, right? And that, again, that's why I wrote this. Oh, sorry, I moved that little dash here, right? We integrated this, right? So our function, it gives us big F, right? This is big F. This is big F here, okay? And then we're now taking the derivative of big F, right? Derivative of big F is supposed to give us originally what we had inside, right? This is what we originally had inside. Okay. Key thing to look at is that there's actually an equal sign here, right? These two things are the same, right? Makes sense. The derivative of big F is equal to small f. Okay, what are we going to do with that information? Watch. This is what we're going to do with this information. Can I get... can I delete all of this? Yeah. Delete, delete, delete. Maybe not all of that. I need the bracket, technically. Delete, and then I'm going to... Yeah. This is annoying. There we go. Okay, I got it. So we actually have this now, okay? Oh, I'm black. I prime of t, okay, is equal to 0 to 1. Boom. This is what it's equal to. Okay. Du. Remember, we took the integral of this in respect to t, okay? Which gave this is the integral, okay? And then when we take the derivative of it, we get back the same thing, right? So I'm gonna write it out explicitly, so that there's no confusion. This here is equal, okay? It's equal to e to the negative t squared, u squared plus 1, 2t. Yeah? Remember, all those terms cancel out when we're left with this, okay? This is the same shit as this, except we have a du here, right? And I plug it in. It's there. It didn't disappear anywhere. So now that we have this is where the real magic happens, right? And the reason why it's kind of called this like inverse Feyman technique. Again, I'm gonna restate that the Feyman technique, okay? Feyman technique is this idea of you have like some integral, okay? Like I don't know, like f of x integral, right? And then you want to put some parameter here, okay? I don't know, let's say a, right? And then now you differentiate in respect to a. And it's supposed to make it easier, okay? That's the whole idea. Here, I mean, we kind of did that, I guess. We're kind of like undoing it, sort of. Undoing our derivative inside, right? We did differentiate to some extent. Anyway, that was a bit of yapping. Let me show you the real algebraic magic here, okay? What is this? What is I prime of t, okay? It's d by dt of I, right? That's what it is. It is the derivative in respect to t of our function. this is equal to this here is not a u term, right? This is an integral in respect to u. D by dt it has nothing to do with u. It's actually it's an operator, but essentially the idea here is that it's a constant in respect to this integral. It comes out. We have d of dt on the outside, okay? 0 to 1 of the whole stupid jargon that I wrote in here, e to the negative t squared, u squared plus 1 over u squared plus 1. That's an ugly one. du. I'm getting sloppy, right? This comes out, and I mean, look, I'm just gonna boop, boop. They cancel. We've essentially integrated our function by canceling out the derivatives, right? Or I could just like do this, right? Like differentiate, or not differentiate, but integrate in respect to t. Anyway, in whole, the derivatives cancel out. That's what I want you guys to notice, okay? And we have now I of t is equal from 0 to 1. Oh my god, this is getting crowded now. 0 to 1, 0 to 1 of negative e, negative t squared, u squared plus 1 over u squared plus 1 du. And remember, guys, when you're doing an integral, can't forget plus c. It's very important. So this plus c is actually basically what's going to give us the answer here. Okay, let me copy this thing now. Control X, and then I can delete all this top part here. Thank God. Okay, look at that. Look at that. Okay. Now we want to find what c is equal to. Okay, how are we gonna find what c is equal to? Now, I'm gonna write on the side here, right? What was our original? Okay, not original. What was our second to most original integral? It was I of t, right? I of t is equal to 0 all the way up to t, right? Oh shit. Square root actually. Okay, whatever. 0 to wow. You know what? I got rid of it. Wow, I got rid of it. I have t. They're the same. Okay, and I'll keep it consistent. So I have t of what is it? E to the negative x squared dx. I think this is squared, right? Yeah, this was our original integral. Okay. When I of t, okay, is equal to 0, so when t is equal to 0, sorry, of I of t, what do we get? We get the, am I going to write it out? No. Okay, listen, guys. Look at this, right? T is equal to 0. What do we get? We get this integral of 0 to 0 of some function, right? Is equal to 0. Is the key takeaway of that. It's equal to 0, right? It doesn't even need to be 0 actually, but the bounds need to be the same, right? Integral from a to a, right? These are the same shits. F of x dx is equal to 0, right? Area of some function, same point. This area right here, this strip, it doesn't exist. There's nothing. It's 0. Okay, that's like FTC part 1, I think. So 0. Okay, I of t when t is equal to 0 is 0. Nice. So if I write I of 0 for this function, okay, let's square this off. This is equal, it's from 0 to 1, right? Negative e to the negative 0, 0, right, squared, u squared plus 1 over u squared plus 1 du plus c. Okay, 0 times something is 0, so it's actually e to the 0. What's e to the 0? Well, anything to the 0 is just 1, right? So that must mean that we actually have 1 at the top here. So it's 1 over u squared plus 1 du plus c. And remember, I of 0 is equal to 0, right? I stated that here. So 0 is equal to 0 to 1 of 1 over u squared plus 1 du plus c. Okay? What is this, guys? Like I said, this should have sent off alarm bells at the beginning, right? The u squared plus 1. It's arctan, okay? It's like obvious, I think, anyway. Well, it's obvious to me because I've been burnt by it so many times I forced to remember it. So, oh shit, hold on, wait. A to 0 is equal to 1, but I have a negative sign here, okay? So it's actually negative arctan. Yeah, that's my bad. But yeah, because then we do minus c, but then the negative sign here cancels this out, so it's actually just c, right? Because I have to minus, and then but the negative, so c is equal to arctan, right? So I'm gonna write this as arctan of u from 0 to 1. So what is that? I hope you guys know your unit circle, or else I don't even know what. Don't deserve to be cal exec, I guess. Arctan of 1, what is it? So it needs to be, it's right, it's sine over cos, so it has to be some angle where, you know, they're the same, denominator and numerator. So it's 45 degrees, pi over 4. So we have pi over 4, right? And then what's arctan of 0, right? What angle gives us 0 for the tan function? It's 0, right? When the angle is 0, sine is equal to 0, tan cosine is equal to 1, but it doesn't matter because 0 over anything is 0, except for 0. 0 over 0 is not 0, but I digress. So minus 0, right? Therefore, pi is equal to, c is equal to pi over 4. Okay, nice. C is equal to pi over 4. Now what? Right? Now what? Well, watch. Watch this. Gonna be crazy. Boop. I'm gonna get rid of that because it's actually just pi over 4, right? So we have this, right? Remember this random jargon shit I wrote at the beginning, right? Now we get to plug it in. Fun. Fun, 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 fun. We get to plug it in. I get to plug in limit of t goes to infinity, right? Of 2 times the square root of, can I copy this, please? Yes, I can. Of this. Shit. Okay, I can just redraw it. Doesn't matter. Whoop. Like that, right? Okay, let's evaluate this, right? Uh, t goes to infinity. So let's look at that. T goes to infinity, okay? Limit as t goes to infinity of negative t squared of, I guess I'll write the rest of the terms, u squared plus 1, right? T goes to infinity, I mean, it just consumes all of this, right? So it's basically just e to the negative infinity, right? And I mean, what do you guys think this is, right? If I have I'll draw the function for you guys actually, right? This is what the function looks like. Whoop, right? It's an exponential, but oh, what's going on the other side? What what's this? Oh, it approaches zero. Okay, right? Some something to the power of a negative infinity is always going to be zero. Well, maybe not everything, but that's generally the case, right? You're bringing it to, I mean, you can even write it out mathematically, right? It's e to the infinity, right? And this is infinity, so 1 over infinity is 0, right? There you go. So, right, 0. That means that our whole upper term right there, right? So, I mean, yeah, I'll keep writing it. Limit t goes to infinity. 2 times the square root from 0 to 1 of 0, right? Everything consumed by the limit of e to the negative t squared consumed. It's just 0 on the top over. I'm not gonna write it. Doesn't matter. It's 0. It's du. It's 0. There's no integral anymore, so it's 0. So we get pi over 4. Okay, pi over 4, right? So I'm just gonna write this out. Pi over 4 times 2 is equal to 2 times the square root of pi over 2. 2's cancel out, equal to square root of pi, right? And what is all this jargon? Well, we've essentially written that limit, right, as t goes to infinity of 2 square root of I of t, right? That's what I of t is. I of t is this, okay? I of t is all of this. This is I of t, okay? This is equal to 2 from 0 to infinity, right, of e to the negative x squared dx, which is also equal, okay, from negative infinity to infinity of e to the negative x squared dx. That's our original integral. This is our original integral, right? The answer is square root of pi. I What does e have to do with pi? I don't know. Like probably something to do with the complex plane. I mean, like e to the I x, or I theta rather, is equal to I sine theta plus cos theta, right? This is a complex function, right? So there's some relationship between the two, but besides that, yeah, it's a little weird. It's kind of weird that e has a relationship with pi, square root of all things. Anyway, that's the proof. If you guys have any questions or anything that's confusing, do let me know. I don't even know if you guys are going to be able to watch this in time, because AP is literally tomorrow in like 12 hours almost. Anyway, if you did watch it all, thank you. And, well, hopefully I see you guys tomorrow at AP. Thanks, guys.